Hello everyone, once again this is apt-s, and today we're going to be going over big O notation, and today we're going to find out what exactly big O notation is. So let's get down to business now. So in big O notation we have what we call basic types, and the seven basic types are these right here that I've listed out. We have order 1, we have order n squared, order 2, and order log n log n, and order n factorial. And these are very common notations that we have in our algorithm. So what a big O notation means is it describes the performance or complexity of an algorithm, most generally the worst case scenario. So generally it describes how many iterations it will take to complete a process or for an algorithm to complete, with order 1 being the simplest and the most desirable. Here I have a graph of the algorithms and just their curves. So you can see the rate at which they change and generally how many iterations it will take for an algorithm to complete. Obviously, order 1 would be the most desirable here that we have, with order log n being the next. You can see that order n factorial is the worst case, and is generally the thing that we kind of want to avoid in programming. Some problems we're not going to be able to avoid it, such as the traveling salesman problem. Sometimes there's just no other way to think of writing an algorithm such that we can avoid the iteration complexity of it. So generally, this is an undesirable order that we don't want. Similarly, order 2n, or this exponential um, notation right here, it's also something we want to avoid, with order n squared being a quadratic. It's not as desirable, but it's better than these two nevertheless. So I'll just go over a couple of these. I'll explain the other ones in other videos where I can actually address a specific problem that we face in computer programming. So let's just go over the very basic. What is order 1? What does it mean to be order 1? When I say order 1, all it is it just means that it takes one iteration or one time to do something. So if we were trying to access an element of an array with 10 elements. So here we have 10 elements, their elements being 1 through 10. The number of iterations it takes to access this one would just be 1. We could easily just access the first one or the second one or the last one. It wouldn't really matter. So the complexity of that algorithm of accessing an element is just order 1. Now we have order n. Generally, order n is used with linear search or something similar to that. And when I say linear search, is if we wanted to search for a value, a specific value in this array with 10 elements, well, the worst case scenario that it would take to find the value we were looking for would be 10. Let's say if the value we were looking for was the last one, which is 10, we would have to go, and this was unsorted. If we didn't know its location like we do now, because well, this is sorted, so it would be easy to find it. It would just be order 1 if it was sorted. But if this was unsorted, it would take 10 iterations before we actually found our value, and that's the worst case. Being the best case being order 1, because if the value we're looking for was just the first one, well, that would be easy to find. That would just be there. That is the best case scenario. But generally, we describe our algorithms with the worst case. And order n, well, it's just linear. Its rate of change is linear, so it's dependent upon the number of items that it has. So the worst case in this array would be 10. If the array was bigger, let's say 20, well, it would take 20. Or if the array was 50, it would take 50 iterations before it found the right one. And that's the worst case. It could easily take half the time, or it could easily be the first one. We don't know, so it's different each time. We also have what we call, and I'll go into explaining order n squared, or the quadratic algorithm. And so this algorithm is usually noted with a double nested loop, or a double nested for loop specifically. And what I mean when I say double nested loop, it's just a loop that has a loop inside of it, and it would take n squared times, because we want to go through that loop n, the main loop n times. We want to go through the inner loop n times, and so that's n squared. So n times n is n squared. If we had a triple nested loop, that would be n cubed, which is just n times n times n, just n times itself 3 times. So that would be n cubed, and we could easily do n to the 4th or n to the 5th, and it just goes on for however long your loop is. And the order n squared is a very common algorithm that we find. It's not really desirable, but it pops up, and sometimes there's just the only way we can do it. Well, let's go on. We'll skip this one, the order 2n. Just because it's a little bit more complicated, and I'll talk about this problem in a later video. But let's focus on the order log n, a binary search tree. And generally, when we see order log n, it's relevant to a binary search tree or something similar. It's a divide and conquer algorithm. What I mean by divide and conquer, it just takes the middle item. So here we have a number line. It takes the middle item, and it asks, is the value we're looking for less than or greater than? If it's less than, well, we just go to the middle item here, and we'd ask, is the value we're looking for less than or greater than? If it's less than, we would go over here, and we ask, is it less than or greater than? Well, it's greater than, so we'd go here, and we'd eventually find the value we're looking for. So it's just a divide and conquer. And I'll show this with an example, a better example right here. So here I have a bunch of 1s and a 0, and these are 16 items in total, and you can count them if you want to, or you can just believe me. And so let's say we're looking for the 0, and we're using a binary search, and so we're going to use the complexity of this algorithm will be order log n. And something to note, I don't know why this happens, but this is base 2, is not base 10. If you ever see this algorithm in computer science or in programming, you're going to see it log n, and just remember that this is base 2, not base 10. So order log n. So we have 16 elements, so n is 16. And so what we do is we would start in the middle. So 1, 2, 3, 4, 5, 6, 7, 8. We'd start around here, and we'd ask, well, is the item to the left or to the right? And we'd say, well, it's to the left. And so we would just get rid of these elements right here. Just delete those. And then we would go to the middle. So we'd go about right here, and we ask, is it to the left or is it to the right? And we'll say, well, it's to the left. So we would get rid of these ones and just focus on these ones. And notice that right there is 2 iterations. We have done that twice now. And so now we're going to do it once more. So we go to the middle one right here, and we ask, is it to the left or is it to the right? Well, it's to the left. So we'll just get rid of these 2. That's 3 iterations that we've done so far. And now we're here. And so now we're just down with these 2, and we'll just ask, well, which one is it? Well, it's this one. So we'll just get rid of this one right here. And that is 4 iterations in total. And just to show you this, so we use the algorithm order log n, right? And so this is base 2. I'll just leave the 2 there so you can see that. And so in this case, we have 16 elements. So the size is 16. So order log base 2 of 16 is equal to 4. And as you could see, that did take 4 iterations. So that's the worst case scenario for that algorithm. It could easily just have taken 1 iteration or more, a little bit more, 2 or 3. And the worst case is going to be 4. And so order log n describes the worst case scenario of our algorithm. Now I'm going to talk a little bit about order n log n, and this is very similar. And so you really generally see this with merge sort or the quick sort algorithm. This basically it does what it is it's n times log n. So this is multiplying log n, and so we basically just do a binary search. We do a divide and conquer algorithm, and depending on the size, so if n was 16, this is base 2, remember, then it would take, the worst case would be 4 iterations, and we just take 4 multiplied by 16 because we want to do it 16 times. All the other ones I will go over in another video. I really hope this helped in your understanding of big O notation, and I hope to see you soon.